Students, today we are going to discuss some important point. Suppose this is a conductor. This is a AB is a conductor. And length of this conductor is AB equal to suppose 2 meter. Then through this 2 meter length, suppose 1 ampere current is passing. Okay, look, AB is a conductor of length 2 meter, and through this wire, means through this conductor, current 1 ampere is passing. Suppose if you going to extend to 4 meter, suppose if you going to extend this 4 meter length, if you going to extend this conductor 4 meter, it means double than the previous. Then now how much current is flowing? You see, if length is making double of the conductor, first time you look 2 meter is there. When length is 2 meter, then current is passing through this conductor is 1 ampere. But later on we increase the length 2 meter to 4 meter, we increase. Then now how much current is increased? The current become half. Okay, understood? When, that means when length of the conductor is making double, then current gets half. Okay, current is decreased to 1/2. 1/2 of 1 means 1/2. Okay, again look, suppose this is another conductor. This is cross section area. This is okay. Cross section means what? Suppose this is a wire AB. This AB is a wire. Okay, if you cut it in this position, then shape will become like this. Okay, this is called cross section. This position is called cross section. So look here, suppose here 0.5 centimeter radius. Okay, the area of cross section here, radius is how much? 0.5 centimeter. Suppose through this wire 2 ampere current is passing. 2 ampere current is passing. If you extend this area of cross section of the conductor, but length is same, suppose radius is become 1 centimeter. First time it was 0.5 centimeter, now 1 centimeter. Okay, now that means area of cross section is increasing. In this area. Then what you have? Then if area of cross section is increasing, then amount of current also increasing. Amount of current also increases. Understood? If area of cross section is increasing, then amount of current also increase. Understood? But suppose this is a silver wire. This is silver wire. Of 1 meter length, and another also 1 meter, but it is made up of copper. Look, this is also a conductor, but this conductor is made up of silver metals. This is also a conductor. This conductor is made up of copper wire, but both are in length is same. Okay, but do you think that same amount of current is flowing through these two wires? So if both are made up of different materials, but through these two materials same amount of current does not flow. Same amount of current does not flow. That means amount of current is also depend on nature of the materials. Okay, nature of the materials. Then first of all, what you have learned, if current is become half, current is decreasing to 1/2 when length of the wire is making double. Length of the wire is making double. That means suppose first time it was 2 meter length, then when it was 2 meter length, then 1 ampere of current is passed. But when you are making double length, that means you are extend to 4 meter, then how much current will flow through this conductor? 1/2 means half. Okay, that means current is decreased to 1/2 when length of the wire making double. Okay, next look, if area of the cross section is increasing, then ammeter reading is also increasing. That means current is increased when area of cross section of same material in the same length is used. Next, there are two conductors. One is made up of silver metals and other is made up of copper wire, but both have same length. Then through these two wires same amount of current does not flow. That means if nature of the materials is different, then flowing of current, the value of current is also different. Resistance. Resistance of the conductor also depend on some factors. if if length of the wire is increases, if length of the wire is increases, then resistance is also increases. If length is decreases, then resistance is also increases. Okay, then on what factor resistance of the conductor depend? Number 1, resistance of the conductor is depend on its length. Resistance is depend length of the conductor. Length of the conductor. If length of the conductor is increasing, then resistance also increases. That means if resistance is expressed by R and length of the conductor is expressed by letter L, then R is directly proportional to L. Means resistance is directly proportional to length of the conductor. That means if resistance is increased, length of the conductor, if length of the conductor is increasing, then resistance also increasing. If length of the conductor is decreasing, then resistance also increasing. So it is called directly proportional. Again, resistance is also depend on area of cross section. Resistance is also depend on area of cross section. Okay, how? Resistance is inversely proportional to area of cross section. Okay, that means this is 1 by A, 1 upon A, means it is inversely proportional. That means if area of cross section is increasing, resistance may be decrease. Okay, if area of cross section is increasing, resistance is decreasing. If area of cross section is decreasing, then resistance is increasing. Okay, that means, so this is suppose equation number 2. First of all, what you have learned, resistance of the conductor is depend on its length. Again, resistance of the conductor inversely proportional to the area of cross section. Okay, if area of cross section is increasing, resistance is decreased. If area of cross section is decreased, then resistance may be increased. So now, if you are going to combine from 1 and 2, what you will get? R is L into 1 by A. Okay, look, resistance is directly proportional to the length of the wire and inversely proportional to the area of cross section. Okay, what? Resistance, R for resistance, L for length of the conductor. Resistance is directly proportional to the length of the conductor and resistance is inversely proportional to the area of cross section. So R L by A. Now you remove this proportional sign, then at the same time you have to put equal sign and also a constant of proportionality L by A. Okay, this is called rho, RSO. RSO. Rho for what? Constant of proportionality. This rho has another name, it is called resistivity. Resistivity. Not P, this is rho, Greek letter. Okay, this rho for what? Resistivity. Then SI unit of resistivity is what? Ohm meter. Ohm meter is the SI unit of resistivity. What is the SI unit of resistivity? SI unit of resistivity is ohm meter. Then what you have learned? Look, resistance of a conductor is depends on its length, number 1. Number 2, resistance is inversely proportional to the area of cross section. Okay, so from these two, if you going, then what do you get? R is directly proportional to the length and inversely proportional to area of cross section. Then R is proportional, then L by A. Now try to remove this symbol. At the same time you have to put a equal sign and a constant later. This constant letter you are putting in place of proportionality. So it is called a constant of proportionality, but this symbol is called rho, RSO, rho. Okay, this symbol is called rho, RSO. But this constant has also a definite name, it is called resistivity. Okay, the SI unit of resistivity is ohm meter. Then there is also another one factor, the resistance of a conductor also depend on nature of the materials. Nature of the materials. The number 1, resistance of the conductor depends on length of the conductor. Number 2, resistance is inversely proportional to the area of cross section. Number 3, resistance is also depend on nature of the materials.